Hey everyone, welcome back. In this video, I'm going to merge a few topics from my previous videos and discuss how using both ODO and S2I can help speed up the inner loop process for developers while making development as easy as possible on the developer and the development teams. You might know the old Einstein maxim, keep things as simple as possible without being simpler. In other words, we should keep it simple and not lose functionality. So let's discuss the problem. What problem are we trying to solve for here? Well, we know the coding for the cloud is challenging. Sure, containers change the way that organizations deploy their apps, but how are they addressing security concerns? Sure, code for the cloud sounds easy, but like so many things in life, it's more easily said than done. And we know that in business, that the fast eat the slow. If that were not the case, then there would probably be one company that controls everything. But the way startups and organizations move quickly is that they iterate fast, and the fast eat the slow. And we know that when developers start trying to bang out that new idea locally on their laptop, it presents problems. Hey, it worked on my laptop. And there are always going to be slight differences between the development and production systems. And another challenge here is how fast can other people review the app and any changes? And finally, the developer wants to make sure that they're not using things like privileged containers, exposing any unnecessary ports, maybe adding binaries that don't necessarily need to be there, and so on and so forth, leaking any credentials like Kubernetes secrets and so on and so forth. That's all kind of burdensome on the developer. And oftentimes those organizations are siloed where you have security and networking and ops. They all got to kind of work together to make sure that they're addressing those things. But what if you had a couple of tools that could kind of take care of some of that stuff for you, or a lot of that stuff for you early on in the interloop process? And here's a great illustration here from someone at Red Hat. With that kind of illustrates the inner loop process that eventually moves to that sort of outer loop process, where in the beginning here you're building, testing, experimenting on code changes, learning from any of those changes, and eventually you have a product that ships. And in summary, a developer codes, gets the feedback, aligns with the teams and the team's objectives, and makes improvements that hopefully goes into a shipping product. So the solution here, the way to sort of simplify that is, again, kind of going back to those two previous videos I did, is to use a product called OpenShift Do, or ODO, which is a developer-focused command line tool for blazing fast Kubernetes application development. And although it says OpenShift Do, it is actually offers first-class support for all Kubernetes systems. And the objective here for ODO is for the developer to spend less time maintaining Docker files and kube manifests and more time coding. And every time the developer makes a change to the code, ODO picks up that change and immediately pushes it to a destination Kubernetes system so that the developer can review the code in an environment that hopefully closely matches what is eventually going to be in production. And ODO's value to the developers, it's really focused more on that inner loop process and developing for those modern frameworks such as Node, Spring Boot, maybe .NET, PHP, and so on. But the developer doesn't have to use some sort of web-based interface. You can still do that local coding, building and running, but without having to have extensive knowledge of either the kubectl or the OpenShift OC tool. And again, this ODO can help abstract away a lot of that complexity so that developers don't have to dive into those complex Kubernetes YAML files. ODO is going to abstract it all away so the developers can code and deploy fast. And then finally, okay, you got that great app. Now I got to build a container. Oh, geez, what runtime am I going to use? What am I going to use for my base image? What are we standardizing on? S2I is another open source project sponsored by Red Hat that has a goal of making it as easy as possible for the developers to build reproducible container images. And the S2I will then take the developer's code and inject it into a container image, and then support doing incremental builds, which will reuse all those previously downloaded dependencies and artifacts and so on. So with that, enough talk. Let's get to it. Let's show how using these tools can make your life a lot easier.
All right, so let's use a fun example here. We're going to clone a Node.js duck hunt game to my local laptop. And now I will cd into that directory. And now I need a Kubernetes cluster. Okay, so I need some kind of Kubernetes environment, and Red Hat provides a free one over at developers.redhat.com. So I'll log in with my personal account, and then I'll click on Start Your Sandbox for free. I'll click that one more time, and that will redirect me over to an OpenShift Kubernetes cluster. I'll click on Dev Sandbox, and this is creating my account for the first time. So I'll just be patient as OpenShift creates my developer sandbox. And once that is done, I should see the OpenShift web UI. There it is. Now I just click on the top right-hand corner there, click on my name, and I'll click on Copy Login Command. And I'm going to expose the API key, which I'll copy to my clipboard, and I'm almost ready to go. Okay, so let me paste that into my terminal. And it says now that I am logged into the OpenShift cluster. Let's see, who am I? Yep, that's me. So now I need to create what's called a dev file, and Odeo will help create that for me. And so it looks at my source code. It says, hey, this is a Node app. That is correct. And since I'm going to code against a live cluster on the web, I just need to add port 8080 so I can clean up those other ports. Those aren't needed, so I'll just type in 8080. That looks good. All right, my configuration is correct. I don't think I need to add any other kind of environment variables. So I'll just go with the defaults here. Yep, Duck Hunt is fine for the name. And I'm ready to go. So now Odeo has created a dev file for me, which is an open standard backed by AWS and Red Hat that helps define that containerized environment. So let's take a look at it here. And you can see that Odeo has created this nicely formatted YAML file that's going to run things like npm install. It's going to, there's the endpoint that I need exposed, which is port 8080. It's automatically selected an open source container image for me, the universal base image, which is based on Node.js, the latest. And there's my origin for my files and whatnot. So yeah, I'm ready to go here. Now I just need to type in Odeo dev, and Odeo will start creating a pod inside my developer sandbox. So there we go. Pod is pending. Pod creation is pending. Pod is now running. Now I need to synchronize my source code files into that container. So Odeo will take care of that for me. And I'm almost ready to go. I can see how my source code will look when running in a container on a Kubernetes environment. Okay, here we go. All right, so if I switch back over to that developer console here, I can click on the URL, and there is my Node.js Duck Hunt app ready to go. All right, let's take a look at my app here. All right, everything seems to be working. It's pretty responsive. Everything's kind of nice. Now, if you look here over in the terminal, you can see that Odeo is watching my local source code directory for any changes that I might make to my source code. And what's really nice about this is that any changes that I might make will automatically synchronize to my Kubernetes development environment. So let's say here, just to make just a very, very tiny change, I'm going to change the title page from Kube Hunt to Pod Hunt. And well, let's watch how Odeo picks that up. So I changed the index page here. And now it's going to synchronize that change and rebuild my container for me automatically so that I could observe what the change looks like and make sure that that's exactly what I want. So I go back here to the console. I click, OK, my application's not available just yet. Got to wait for that container to rebuild. And there it is. And yes, boom. My title page has changed. This looks great to me. Okay, so now that I'm satisfied with my code changes, I need to terminate my connection to the cluster. So I'll hit Command-C, and Odeo will drop the connection to my sandbox environment, which in the process will automatically spin down the pod that's running in the sandbox. So now let's containerize our great application. I'm going to commit the source code changes that I made in my Odeo development session. I'm going to commit those up to my GitHub repo. So here, change title and some other stuff. Good enough. And I will push those changes to my GitHub repo. Great. Now I'm ready to use software to image to build a container with my source code. So I will use S2I to build a Docker file based on that source code using the open source universal base image, just running that command, and voila, within 2 seconds, I now have a Docker file. Let's take a look at that Docker file. So I'll type in vim, Docker file, and there it is. Pretty simple. I'm going to base it off the universal base image, the Node 16 universal base image provided by Red Hat. And S2I will take care of the rest for me. Now I'm ready to use either Docker or Podman to build my container. Recently, Docker made some changes in their licensing to Docker Desktop and how they'll handle registry management for some not-for-profit organizations. So let's look at some alternatives. One that I like to use is Podman, which is fully open source. Podman is compatible with Docker commands. So instead of using, for instance, Docker build, you run Podman build. There's no learning curve there. So we're going to use Podman here to containerize that Docker file. So instead of using, again, Docker build, we'll just use Podman build. And you can see here, if you've ever used Docker to build a container image, it's the same thing using Podman. So we'll let this build here on my local laptop. And then once that's done, I will use Podman push. Just as I would with Docker push, I will use Podman push to send that container image up to Quay.io, where I have a free account. So Podman push up to my Quay account, into my Duck.js repository. I take a little bit of a minute here. Okay, and there it is. It is now available to me here on Quay.io. And as you can see, instead of using, if I wanted to pull this down ever, or somebody else to pull this down, instead of using Docker pull, I just use Podman pull. You can still use Docker pull, by the way. Quay.io is a real nice alternative to Docker Hub. Um, so definitely check that out when you get a chance. Again, you can get a free account. So let's deploy that container image to our free developer sandbox. So I will click on deploy an image, and I'll paste that URL in there. I'll click on create. And we will let OpenShift pull down that container for me. Let's click on view logs. Yep, loading the log file is going to pull it down pretty quickly here. Take a look through the YAML deployment file. And I'll just click on the topology view. And this should pull down pretty quickly because the universal base image that we use is pretty small. And let's see here, is our application ready? And there it is. So now I can take this URL and send it around to people and say, hey, what do you think of this great duck hunt app that was rewritten in Node.js? And that's it for the demo. I appreciate you watching. Please leave any feedback in the comments below.